All right, so in section 7.2, we're verifying solutions. So as we do these, we're going from a general integration or antiderivative equation to the particular solution where we're finding out what that constant C is. And so they're going to give us some initial conditions. We go anywhere from starting with the first derivative and at times the second derivative. And have to go all the way back to the original equation with the second derivative. So those are the ones like problem number 3, we got to be careful that we plug in the right values as we solve for the first C and then going back for the next one. So remember, you can always check when you take the antiderivative, take the derivative of it, make sure you did it right. So they tell us our differential equation, dy dx is equal to e to the 2x minus 2x squared. And we want the particular solution and then this y of 0 is 4. So that's going to help me find what the c is and stuff. Instead of me having a plus c at the end, now I have a y-intercept that's going to be there on my equation. So again, depends on how much notation you want to write. I'm going to write like carefully. I need to find the antiderivative of dy dx so that I can figure out what y is. So I'm going to integrate both sides. So again, you can split it up by parts if you want to split it up by parts. If here, since our exponent is 2x, we could use the u substitution. You don't have to if you keep track of it. So we know the antiderivative of e to the x is just e to the x, so it's e to the 2x. I need to make sure I divide that by 2. That way when I take the derivative of that fraction, the 2 goes away and I'm left with e to the 2x. Next one would be negative 2x cubed over 3. And then I have my plus c. Now I'm ready to figure out, well, what is that c? And that's where that initial condition up here comes into play. So I know the answer is 4 when 0 is plugged in for the x's. Be very careful. It's easy to make some goofy mistakes here. So e to the 2 times 0 is e to the 0, which is just 1. So it's 4 is equal to 1/2. That next fraction is 0 plus c. So really, c is equal to whatever 4 minus 1/2 is. 7/2. Thank you so much. So c is equal to 7/2. All right, we're going to just make it easier and write 3.5. Because we can write decimals, we're allowed to. So my y equation, e to the 2x over 2 minus 2x cubed over 3 plus 3.5. Now, problem number 2 here says this problem is exactly the same. The curve has the slope of, so again, if they rephrase the problem, they just wanted to show you an example here that the problem could have been rephrased as this second one. We're still doing the same thing. Instead of they telling us that, hey, dy dx is that equation, they use the terminology slope. Remember, we're supposed to remember dy dx is the slope. And so we would just end up doing the exact same thing for this problem. It just has a little different starting point in phrasing. Number 3, that we're starting with the second derivative. They want us to find what the original y equation was. So we got to go back to the first derivative, then back again to the original. So this is where there's a very little room there, and so there's a lot of, I'm going to use, we can use. You want me to show you u substitution, or can you do u substitution in your head? Want me to show u substitution? No? Do it in your head? Okay. So as we find dy dx, I know I have to do the antiderivative of 1 over x squared plus 1 minus 2x quantity squared dx. So I got to find that. So dy dx is equal to, that would be negative 1 over x. And then now this is where I have to have my, remember the u substitution part. So plus, it would be 1 minus 2x to the first power, to the third power over, we got to do a 3, but then remember we got to take the what's on the inside is a negative 2, so I got to multiply by a negative 2 down there. And then I have a plus c. And so I'm going to clean that up a little bit. dy dx equals negative 1 over x. And then that's really minus 1/6 times whatever 1 minus 2x cubed is, plus c. And then now I'm ready to substitute in the first condition. I know that when 1 is put in for x, the answer is 7/6. So 7/6 is my answer when I do negative 1 over 1 minus 1/6 times 1 minus 2 times 1. That's being raised to the third power, and then plus c. So 7/6 equals negative 1. Let's see, on the next part here, it'd be 1 minus 2, so that's negative 1 cubed would be a positive 1, so that ends up being, or sorry, be a negative 1, so that'd be a positive 1/6 plus c. So this is 7/6 equals negative 5/6 plus c. And then when I add the 5/6 across, I get c is equal to 12/6, which is equal to 2. So now I know the first derivative equation. Specifically, I know that, I'm going to try to scoot up here, dy dx is equal to negative 1 over x minus 1/6 times my 1 minus 2x cubed. And now I can go ahead and put a plus 2. Are we good so far? I'm going to pause just to make sure. Now we need to do the antiderivative of that. So to find y, I got to do the antiderivative of that equation. Now, do you need to write that step down? You don't have to. I just got to show you what I'm writing down. So now we're going to be careful. Y equals 1 over x is ln of x, so this is negative ln of the absolute value of x. And then I have negative 1/6. I need to make the exponent of 4. So 1 minus 2x to the 4. That means I got to divide by that 4, and then also on the bottom do another times a negative 2 down there. So times a negative 2 again. And then we have plus 2x plus c. And so I'm going to clean that up before I substitute in the last condition of putting in a 1 and getting 0. So y equals negative ln of absolute value of x. Negative times a negative is a positive. That would be 6 times 8 is 48. So 1 over 48 times 1 minus 2x quantity to the fourth plus 2x plus c. And then now I'm ready to solve for that c. So I know the answer is 0 when I put a 1 in. So the negative ln of 1 plus 1/48 times 1 minus 2 times 1 to the fourth plus 2 times 1 plus c. So 0 equals, that would be 0. Then it would be plus 1/48, because it'd be 1 minus 2 would be negative 1 to the fourth is a positive 1, and then plus 2 plus c. So I'm going to move the 2 over and the 1/48 over at the same time, but I'm going to make the 2 be 96, and negative 96 over 48 minus 1 over 48 equals c. So c is equal to negative 97/48. And then now we get to write our nice final answer, our original equation, specifically particular, y equals negative ln absolute value of x plus 1 over 48 times 1 minus 2x quantity to the fourth plus 2x minus 97 over 48. Lot of junk. Easy to make goofy mistakes. Again, make sure the absolute value bars are on the x, on the ln. Okay, make sure you have those there. Don't want to lose a silly point for not having that correctly, because they'll have that as a stipulation. If you leave that absolute value bars off in that one, then, you don't get the point for the correct answer. Okay? Showing the correct dy, dx, and those things, that's what they're also giving points for, having the notation down. So that's why we want to make sure we're writing it as we do it. Any questions on that problem? All right, next part. We should be able to fill this in real quick. We know the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. And so the antiderivative of sine x would be negative cosine x, what? Plus c. And then that one would be sine x plus c. How many of these we got to do? One. So, now remember, I already did all the practice problems. There are some doozies in here. Okay, they're just long. Let me put it that way. So notice they give me they say for what value of k will this problem need to be such that the second derivative of the problem plus 25 times the original problem equals that answer. All right? So here's what we're typically going to do. One, we know that we need to put in, right next to the 25, we got to put in the original problem. We're going to substitute that in. Okay? Remember, we can't solve a problem when there's multiple variables in it. But if we can isolate it down to one variable, we can solve for that variable. And so I know k is a variable, but it's a constant. And so we're okay. Equals negative 82 e to the negative 4x. Now what I got to do is I need to figure out, well, what y double prime is. That way I can substitute that in the first part of the equation. So somewhere, I'm just going to do it over here to the side. I'm going to figure out, okay, if y equals k e to the negative 4x minus 2 sine of 5x, y prime is equal to negative 4k e to the negative 4x minus 10 cosine of 5x. Now, I chose to go ahead and do instead of doing u substitution, just knowing that the derivative of that little exponent was going to come out front eventually and multiply it. And then the derivative of the 5x is 5. I went ahead and multiplied it by the 10. Just to make it easier to cut out a shortcut step. Now, did I make any goofies yet?
On the left, you put the 2 sine 5.
Do I do the...
Multiply by 25. On the left.
When you substitute the y in.
Oh, I left that off there, didn't I? All right. Sorry, my bad. Now, I see what you're saying. I totally left off the negative 2 sine of 5x. My bad. Thanks for catching that, because that would have really messed stuff up later. All right. Hi. Now, that's the first derivative. We got to find the second one. Y double prime equals negative 4 times negative 4 is positive 16k e to the negative 4x. And then I get to make this a plus 50 sine of 5x. Now that is going to get substituted in before our plus sign. So 16k e to the negative 4x plus 50 sine 5x. Sine 5x. All right. Now let's distribute the 25 into the second parenthesis. So I have 16k e to the negative 4x plus 50 sine of 5x plus 25k e to the negative 4x minus 50 sine of 5x. And that's all equal to our negative 82 e to the negative 4x. Now our goal is to solve for k. That's what our goal is. So the 50 sine 5x and the negative 50 sine 5x cancel. I can go ahead and combine the 16k and the 25k to make 41k e to the negative 4x. And that's equal to negative 82 e to the negative 4x. Well, our goal is, again, to solve for k. So I can divide both sides by 41 e to the negative 4x. And then that leaves me with k is equal to negative 2. Gotta be careful. A lot of spaces to make goofy mistakes. If you need to do U substitution, do U substitution out long way, okay? Do what you need to do, okay? I will just scroll ahead and have you just take a peek. Notice, oh, here's a good one, number 10. You got to plug in the second derivative, the first derivative, and the original equation. That's going to be a long one, okay? Just saying, okay? So, but they're doable. They're not super crazy hard, okay? That one, number 11, you're just going to have to try each one because you're trying to figure out which ones balance, which ones are solutions. So you're going to have to basically do y double prime and y prime for each of those and plug them in one at a time to say, is that the answer? Is that worked? Is it? And so forth. Okay, so that's probably the longest one.